Hey everyone, in this video I'll be giving you a quick overview of register transfer. And first, what is register transfer exactly? A digital computer system exhibits an interconnection of digital modules such as registers, decoders, arithmetic elements, and control logic. These modules need to work together to perform a complex task, but how do they communicate? Well, they're interconnected to a common data and control paths performing complete digital system. And register transfer refers to the process of moving data between these registers, allowing the system to process and transfer information effectively. So why is it important to have register transfer, or what is the importance of register transfer? These register transfer operations are essential because they define how the data flows within the CPU. Whenever it's moving data between the registers or between memory and registers, the efficiency of this process impact the overall speed of the system.
The register transfer language is the symbolic representation of notation used to specify the sequence of microoperation. RTL is a formal way to describe the action happening inside the computer. Gumagamit ito ng symbols and notation upang mapakita paano gumagana ang data sa loob ng hardware. In a computer system, data transfer takes place between processor and register and memory, and between processor and register and input-output system. Data frequently move between different components. These components include processor register, memory, and input-output system. Processor register is a fast storage located in CPU, while memory refers to large storage areas, and input-output system represent internal device. Notation RO, R1, R2, and so on represent processor register. These register are temporary storage sa processor. And each register ay may kanya-kanyang unique na labels. These labels allow us to clearly specify which register are involved in any data transfer or operation.
The addresses of memory locations are often represented by descriptive names like lock, place, or mem, etc. This allows the programmers and the system to identify the specific locations in memory. It also makes it easier to read and understand. Input-output registers are represented by names such as data in, data out, and so on. Using these kinds of names makes the interaction of the computer systems more simplified. Additionally, the content of register or memory location is typically denoted using square brackets around the name of the register or memory locations. This is commonly used in assembly language to distinguish the address and the data stored within it.
This report delves into register transfer operations, conditional data transfers, and control functions in computer architecture. Registers, small storages, location temporarily hold data while instructions are executed. These transfers can be conditioned on specific signals, enhancing system efficiency and flexibility. So let's start to the main topic. First is data transfer representation. Data transfer between registers is represented symbolically. For instance, R1 to R2 denotes transferring the content of register R1 to register R2. Second is conditional transfer. Transfers often happen under specific conditions. This can be shown using an if-then statement like if P equals 1, then R1 to R2, where P is a control signal. The transfer occurs only when P equals 1. Third is control functions in transfer operations. A control function like P can be separated from the data transfer, making the process more flexible. For instance, P R1 to R2 means the transfer from R1 to R2 happens if the condition P is met. Block diagram. The block diagram illustrates how the control circuit signals the transfer with the data moving from R1 to R2. when P equals 1. In conclusion, understanding this involves grasping the role of control signal in determining where data transfer occurs and recognizing how symbolic representations and diagrams simplify complex operation in computer architecture.
I'm excited to hear about your topic for today. Tell me all about it. What are you interested in exploring? What questions do you have? The more information you give me, the better I can understand your topic and help you brainstorm ideas. The memory address register MAR is a crucial component in a computer's memory system. It holds the address of the memory location that the CPU wants to access. Here's a breakdown. Purpose: the MAR acts as a pointer, indicating the specific location in memory where data is to be read from or written to. Function: when the CPU needs to access data, it first loads the address of the desired memory location into the MAR. This address is then used to access the corresponding data. Relationship with memory: the MAR is closely connected to the memory data register MDR, which temporarily holds the actual data being read from or written to memory. Right. The program counter is a vital register in a computer's CPU that holds the memory address of the next instruction to be executed. Here's a breakdown of its crucial role. Sequencing instructions: the PC acts like a conductor in an orchestra, ensuring that instructions are executed in the correct order. Sequential execution: after an instruction is fetched and executed, the PC is incremented to point to the next instruction in memory. This allows the CPU to seamlessly move from one instruction to the next. Branching and jumps: the PC can be modified to change the flow of execution. This is essential for implementing conditional statements, loops, and function calls. For example, if a conditional instruction evaluates to true, the PC might be updated to jump to a different part of the program. The instruction register is a crucial component within the CPU that temporarily stores the instruction currently being executed. Here's a closer look at its role. Instruction decoding: once an instruction is fetched from memory and loaded into the IR, the CPU can decode it. This involves breaking down the instruction into its individual components, such as the opcode and the operands. Execution: after decoding, the CPU executes the instruction based on the information in the IR. This might involve performing an arithmetic operation, moving data, or controlling the flow of execution. Temporary storage: the IR acts as a temporary holding space for the instruction while it's being processed. Once the instruction has been executed, the IR is ready to receive the next instruction from memory. A processor register, often denoted as R1. Processor registers are like small, high-speed memory locations within the CPU itself. They are used to store data that the CPU frequently needs to access, such as intermediate results. During calculations, the CPU often needs to store temporary results. Processor registers provide fast access to these values. Operands: instructions often involve working with data stored in registers. Program control: some registers might be specifically used for program control, like the program counter or the instruction register. Think of them like scratch paper for the CPU. It's much faster for the CPU to grab data from a register than to go back and forth to main memory. Here's why they're important. Speed: registers are located within the CPU, making them significantly faster to access than main memory. This speeds up calculations and data manipulation. Efficiency: by keeping frequently used data in registers, the CPU can avoid repeated trips to memory, leading to improved performance. Flexibility: registers can be easily manipulated by instructions, allowing the CPU to quickly process data and control program execution. The specific number and purpose of processor registers can vary depending on the CPU architecture. Let me know if you have any other questions about
A bus structure, on the other hand, is more efficient for transferring information between registers in a multi-registered configuration system. This means that instead of using separate wires for every possible connection between the registers, which can get complicated and unwieldy. A bus allows multiple registers to connect through shared lines. This reduces the amount of wiring needed and simplifies the overall design. As a result, data can be transferred more quickly and effectively, improving the overall performance of the system. And next is, a bus consists of a set of common lines, one for each bit of a register through which binary information is transferred one at a time. Control signals determine which register is selected by the bus during a particular register transfer. This means that the bus has dedicated lines for each bit of data, enabling the transfer of bits one at a time. Signals identify which register is active for the transfer, ensuring that only one register can send or receive data at any given moment. This design simplifies communication and helps avoid data conflicts.
In a digital system, we often use multiple registers to store data, but to transfer information between these registers, we need to provide paths. If we were to use separate lines or wires to connect each register to all the others, the number of wires would become overwhelming, especially as the number of registers grows. To avoid this complexity, we use a bus system where a single set of shared wires allows data to be transferred between any registers. This greatly reduces the number of connections, making the system more efficient and manageable while still allowing for fast data transfer.
The following block diagram shows a bus system for 4 registers. It is constructed with the help of four times 1 multiplexers, each having 4 data inputs 0 through 3 and 2 selection inputs S1 and S2. We have used labels to make it more convenient for you to understand the input-output configuration of a bus system for 4 registers. For instance, output 1 of register A is connected to input 0 of max 1. So this is the bus system of 4 register diagram, and this is a control signal mapping S1 and S2 selected register. Then example, if S1 is equal 0 and S2 is equal to 1, then register B will be selected and all 4 bits from register B will be transferred to the bus. Okay. Block diagram overview of a 4 register bus system. Imagine a system with 4 registers A, B, C, and D, where each register stores 4 bits. Transfer any register's data to the bus, we need 4 to 1 multiplexers, 1 for each bit position. Max 1 handles bit 1 from register A, B, C, or D. Max 2 handles bit 2 from the same registers. Max 3 and Max 4 handle the third and fourth bits. This setup ensures that only one register's data is placed on the bus at any given time. What is the advantage of using bus system? Pair wires reduce the total number of connections, making the circuit design simpler and more compact. Scalability. It is easy to add more registers without needing extra connection between each registers. Cost effective. Minimize the use of wires and components, lowering the overall cost of the system. And that's it. Thank you.
Hello everyone, today I will tell you about a bus system called a three-state gate. So a three-state gate is like a switch with 3 settings. 2 of these settings act like a normal logic gates. 1 means on and 0 means off. But the cool part is that the third setting is called the high impendent state, which is like the gate is being invisible or connected. In a bus system, the most common three-state gate is called the buffer gate. It helps control how information moves around. That's it. Thank you very much.
This graphical symbol of a three-state buffer. When C equals to 1, the gate lets the signal from A pass through to Y. When C equals 0, the gate blocks the signal, so Y is disconnected or high impedance. Basically, if the control input C is on, a signal gets through. If C is off, nothing passes through.
The bus line connects multiple buffers. Only one buffer can send data to the bus at a time. These are three-state buffers, meaning they can either send a signal, block the signal, or disconnect from the bus entirely. The 2x4 decoder takes a select signal and enables only one buffer at a time. The selected buffer is the only one that can communicate with the bus, while the others stay in high impedance state. When a buffer is selected, it sends data to the bus. The other buffers are disconnected, ensuring that only one buffer sends data at any moment, preventing conflicts. In summary, the bus line uses three-state buffers controlled by a 2x4 decoder to ensure that only one buffer communicates at a time. Simple, efficient, and avoid interference.
A memory word is represented by letter M. Each memory word holds a data, and the system accesses this data through a memory address. Address register, also known as AR. This register holds the address of memory word to be accessed. It tells the system in which location in memory is to be worked on. Data register, also known as DR. These registers hold the data that has been read from memory or the data that is about to be written into memory. It acts as a buffer between the memory unit and processor. The read operation can be stated as this. This means the data from register R1 is written into memory word at the location indicated by AR. Essentially, the system is storing the data R1 into memory at the address held in AR.